welcome back to the QST YouTube channel. Today we'll be solving the term 1 week 8 quiz for math. Let's go. A lab technician has 2 pints of diluted liquid that he will dispense in identical cylindrical test tubes, each having a radius of 1 inch and a height of 4 inches. The technician fills each tube with diluted acid up to 85% of its capacity. Given that 1 pint is 29 cubic inches, what is the maximum number of test tubes? Okay, so here they said we have 2 pints, but 1 pint is 29 cubic inches, so 2 pints is 58. Okay, now they want us to find the volume so we can divide it by 58. Okay, we need to find the volume of one test tube. Then, okay, we won't use that only. We're gonna need to multiply it by 85% because they said the technician fills each test tube with diluted acid up to 85% of its capacity. So 58 over volume of a cylinder is pi r squared h. Pi 1 squared times 4, which is the height. So 4 pi. So 4 pi times 85%. Let me use it on the calculator. 58 over 4 pi times 85%, which is 0.85. That will give us 5.42. But when it's a decimal, we're gonna take like the whole number, not the one above, which is why it's 5. Number 2. In which interval is the graph f of x equals to negative x cubed plus 27x decreasing? Look, when they're asking whether it's decreasing or increasing, we do the table of variation. So to do the table of variation, we need to find the derivative first. So f of x is equal to, so we derive negative x cubed plus 27x. So we're gonna get negative 3x squared plus 27. Then equate it to 0. So negative 3x squared plus 27 is equal to 0. So negative 3x squared plus 27 is equal to 0. X is equal to 3 or negative 3. Then we're gonna do the table of variation. Okay, x, y prime, y. We're gonna put what we got for what makes the derivative 0 with x in ascending order. So negative 3 here and 3 here. And then let's put 2 zeros on the negative 3 and 3. Now we can use one of the techniques. Look, if it's linear, which I'll just write as LIN, we do OS. But if it's quadratic, which I'll write as Q, like this for example, we will use SOS. But if it's cubic and plus like cubic and higher powers, we're gonna substitute. Okay, we do SOS of the same opposite same of the sign of the highest degree, which is negative 3x squared. So we're gonna use negative 3 as reference. So same, which will be negative, positive, negative. So this means it's decreasing when it's less than 3, increasing in between -3 and 3, and decreasing when it's more than 3. But here they're asking when it's decreasing. So, as we said, it decreases, okay, when it's less than 3 here. Since it's before -3, it's gonna be decreasing. So when it's less than -3, or when x is more than 3, because it's like in the table of variation it's after 3. X greater than 3, which is the answer right here. Number 3. F of x has an inflection point at x equal to a. Look, the inflection point is what makes the second derivative equal to 0. Okay? And not just that, the double derivative will have to change sign when it passes through like x, and then when you substitute like f of x basically. The double derivative changes sign, not the derivative, not the normal. The double derivative, it's all the double derivative and it changes the sign. Only when it's inflection. Only when it's inflection. So number 4. Given a rectangular sheet 4 centimeter by 20 centimeter, equal squares of side x centimeters are removed from each corner, and the edges are then turned up to make an open box. Okay, look. Let me make an example. Let's say this is 20 and this is 4. 20 and 4. Okay. Now we will be taking off x from each corner. X from this corner, x from this corner, and x from this corner, x from this corner. You get what I mean. So, but they want the volume. Okay, in questions like these, always remember that the what's it called again? That the height, because here they're asking for the volume, it's always x. The height is always x. And look, the volume is always the area of the base, which will be a in this case. Just call it a, times height. Then area of the base, so let's say, let me mark it in red actually. The red part is what x was removed basically. Wait, no. Okay, as I was saying, the red part is what x is basically. So here, then let's switch back to green. This, then also from this corner, and here as well. So look, from each side, okay, they removed 2x, right? So x here and x here. Again, they said that the rectangle is the base. So, wait, we mark everything as x. X, 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 x. Oh my, too much x. X and another x. Okay. So, the area of the base should be this green part. This green part. I'll just mark it blue. This blue part of each one, right? And as I said, the height in these types of questions is always x. Just memorize it. It's never anything else. Okay, so let's take it yellow. What would this be? For example, this would be like the blue part would be 20 minus 2x, right? And here, what would this be? 4 minus 2x. The area of the base is a rectangle. So if the area of the base is the rectangle, like if the, oh my goodness, if the shape of the base is a rectangle, the area of the base is length times width. So 20 minus 2x times 4 minus 2x times the height, which is, as we said, always x in these types of questions, is equal to the volume. Now for the condition, this is the easier part of the question. We're just gonna take what makes the smaller one equal to 0, and it will always be less than, like, greater than or equal to 0. So 4 is equal to 2x, x is 2. So if x is 2, it's gonna be greater than or equal to 0, but less than or equal to 2. That's it. You always take the smaller one and make it equal to 0 so you can find out the condition. And the 0 will always be there. Number 6. The surface area of a cylinder with base radius r and height h is given by 2 pi r h plus 2 pi r squared. Its volume is given by pi r squared h. Okay, if volume is 3456 pi centimeter cube, then the surface area in centimeter squared can be expressed by S is equal to B over R pi plus 2 pi R squared, where B is a whole number to be determined. What is the value of B? So first, okay, we need to find the height. So we can substitute it in this equation. Okay, so, and they already gave us the volume. So pi r squared h is equal to 3456 pi. Look, what we're doing now is writing h in terms of r. So let's cancel pi. So we get h is equal to 3456 over r squared. Okay, so now what we're gonna do is substitute in this equation, the one for the surface area. So 2 pi r, and then h, as we said, is 3456 over r squared plus 2 pi r squared. Okay, this r cancels out and then this becomes r, and then we're gonna be left with 3456 times 2 pi, which will give us, let me just substitute it, by 6912 over r pi. Now here comes the tough part. They want to find the minimum surface area. To find the minimum surface area, we need to figure out what makes the derivative equal to 0. So what we're gonna do is derive 4 pi r is equal to, wait, no, not yet. Okay, so 4 pi r is minus 6912 pi over r squared. So what we're gonna do now is take 6912 to the other side, then cross multiply. So 4 pi r, because it's equal to 0, we're gonna have to equate it to 0 and then find r. So 4 pi r is equal to 6912 pi over r squared. Pi by pi. So we're gonna get 4r cubed is equal to 6912. You divide by 4, 6912. Let me put it on the calculator. 6912 divided by 4 over 4 is equal to 1728. Then you cube root the answer. So cube root of cube root of 1728, because from what we did here to what we did here to here, we divided by 4 on both sides, and then I cube rooted it to get 12 centimeters for the radius. Number 6. The surface area of a cylinder with base r and height h is given by 2 pi r h plus 2 pi r squared, and the volume is given by pi r squared h. Okay. V is equal to 2000 pi. Then h is equal to, we're just gonna do like what we did last question. So pi r squared, which is the volume, pi r squared h, is equal to 2000 pi. Pi by pi, it's 2000. So h is equal to 2000 over r squared. Okay, and then for part B, okay, they substituted 2000 over r squared in the equation for the surface area. So 2 pi r times 2000 over r squared plus 2 pi r squared. Then again, pi doesn't go this time. Let me just make it smaller. 2 pi r, it's too small. 2 pi r times this. So r from here cancels here, it becomes 2000 over r. Then you multiply 2 times 2000, so 4000 pi over r plus 2 pi r squared. Okay, we found the answer. Now in part C, they want us to derive. We knew that by seeing ds by dr. So ds by dr. So we're gonna derive. We're gonna do there's a way you can do it, which is 4000 times r to the power of -1, which will give you negative 4000 pi over r squared, because it becomes r to the negative 2, and then you take it down, plus 4 pi r, which is what we have here. Now let's scroll down and do part D. When ds by dr shifts to 0, so that means this equal to 0, r should be equal to, okay. So what we're gonna do now is make this whole thing that I circled now equal to 0. So we're gonna take 4000 pi r squared to the other side. So 4 pi r equals to 4000 pi over r squared. Pi by pi, so 4r cube is equal to 4000. So r is 10. Now let's move to part E. Okay, wait, I solved this part. Okay, look, there is a simple way to solve this. They said the minimum. They said minimum. A minimum in the table of variation looks like this, right? Okay. When they mean this, they're talking about the double derivative. Okay. And the double derivative, what does this mean in the table of concavity? It means that it's positive. So we have this part. And we already found the answer. The minimum, okay, it's when the first derivative is equal to 0, which we found in part A, which is 10. Number 7. This is the hardest question. Mark is on a boat 2 kilometers from the nearest point A on a straight shoreline. Down the shore, 8 kilometers from A is his home B. Suppose that Mark can row 7 kilometers per hour and run 9 kilometers per hour. Whatever. First, let's draw the figure. So, M is Mark. Here is A, where the nearest point is. Look, the nearest point is always perpendicular to the horizontal line, which is MA in this case. And then here is, okay, now look, let's say that the entire from A to B is 8, we said, right? Let's take this point, like this line, as X. This is because he needs to park his boat, because here they said let X denote how far from A Mark lands his boat, which is here in this case, and let T of X denote the total time. Okay, so what will this be? 8 minus X. And they said from A to from where Mark is to the shoreline is 2. Now we need to find this distance. We'll just do the Pythagorean theorem, because as we said, this is 90. This is a right angle, which means that we can do Pythagorean theorem, which will give us radical 4 plus x squared. Okay. But now they want the time. Time t is equal to distance over speed. Okay. So the time will be from M to, let's say, H. M to H. And then from H to B, which is where his home is. Okay. So as we can see here, suppose that Mark can row 7 kilometers per hour. This is the speed of the rowing. So from M to H. So the time of M, so time from M to H is the distance, which is radical 4 plus x squared over the speed, which is 7. Okay. And he can run 9 kilometers per hour. So from H to B, which is when he starts running, is, yeah, you get what I mean. So, and then we're gonna need to, not yet. So time from H to B is gonna be 8 minus x over the speed he was walking, which is 9 kilometers per hour. And then for the total time, we just add these two together, which will give us part A. 4 plus x squared over 7 and 8 minus x over 9. Now let's remove this so we can have space. And let's continue. Now they want the derivative. Look, first let's start with this, the one at the top. We can say it's 4 plus x squared, all of that to the half. This all times 1 over 7, because here the denominator is 1 over 7. Like the denominator is 7, so we multiply it by 1 over 7. Okay, so we're gonna do the chain rule. So 1 over 2 times 1 over 7. Okay, all of that times 4 plus x squared to the negative half, all of that times 2x, because we're doing the chain rule. So after we do the derivative of this part, we're gonna need to do the derivative of what's inside, which is 2x. So 2 and 2 cancel, 2 and 1 over 2 cancel, and then 4 plus x squared to the negative half is 1. You just take 4 plus x squared in the denominator and put a radical on it. Okay, so let's remove this. So now we're gonna get x over 7 times radical 4 plus x squared, which is what we have here. Now for the 1 over 9 part, they want us to derive the 8 minus x to the over 9. So for this, we're gonna split it into 2. So 8 over 9 minus x over 9. 8 over 9 will go, because the derivative of constants that are like added or subtracted is 0. And then for the negative x over 9, x just becomes 1, so negative 1 over 9. Correct. Now they want us to find the value of x that gets Mark to arrive home in the least amount of time. Okay, so simply what we're gonna do is make what we got in part B equal to 0. And then we're gonna just get that. So we're gonna make it to 0. I'll just take 1 over 9 to the other side. So x over 7 radical 4 plus x squared is equal to 1 over 9. So 9x is equal to 7 radical 4 plus x squared. Now we're gonna radical both sides. So let's take it up, basically 81x squared Okay, no, that whole 81x squared is equal to 49 times 4 plus x squared. We're gonna distribute to get, wait, let me just do 49 times 4. Okay, so 81x squared is equal to 4x, wait, no, not 4x squared, 49x squared plus 196. We're gonna take the 49 to the other side, so 81 minus 49, so 32x squared is equal to 196. So now we're gonna do 196, right? Just take everything to one side and isolate x. So x will be equal to radical 196 over 32 radical 196 over 32, which is equal to 7 times 2 radical 2, if I'm not mistaken. Yeah, 7 over 2 radical 2, my bad. Which is what we got in part C. Are there any more parts? No. Number 8. A square of side H is removed from each corner of a cardboard box measured 30 by 30. Sides. We already did this in the first few questions. Okay. So, we have volume is equal to, as we said, the height will be what's taken away. So, height times the side times side, like 30 minus 2h times 30 minus 2h, which is 30 minus 2h squared. 30 minus 2h squared. Now what they did here, okay, they factored out 4. We can factor out a 2, but in this case, since it's squared, we're basically taking out a 4. So 4h is equal to, wait, no, not equal to, not yet. It's 4h times 50, wait, you can take out negative 2, which is basically 4 at the end of the day. H minus 50, doesn't matter. And then again, H has to be between, like, make this equal to 0. It will always be greater than or equal to 0, but we need to figure out where it's less than or equal to, so just make what's in the parentheses equal to 0, which will give us H is less than or equal to 50. That was wrong. And now for part B, they want us to derive. So that will give us, we could do chain rule, but what's better for us, because for part C, we're gonna need it. We're gonna need to, first of all, expand, right? So 4h times h squared minus 30h 15 times 15 plus 225, and then you're gonna distribute, which will give you 4h cubed minus 120h squared plus 900h. 900h. But they want the derivative of this. So we're gonna have to derive it, which will give us 12h squared minus 240h plus 900. And then we're gonna have to factor it. Okay, so 12x squared minus 240x plus 900 is equal to 0. This will give us 15 and 5. We already have 15 here, so the other one will just be 5. The second derivative is we just derive this part again. So 24h minus 240. Now at h equal to b, okay, they want to figure out at h equal to b what will it be. Okay, so at h equal to b, just substitute 24, just substitute h by 5 because we said b is 5. Okay, so 24 times 5 minus 240, it will be negative. So this means it's a sad face, which means it's a maximum, right? Okay, which as we said is h equals b and b is 5. Done for this question. Number 9. Mark is in a boat 2 kilometers away from the nearest point A on the shoreline, down the shore. Look, this is the same question as the few questions. There was a question, exact same numbers, exact same everything, same method, same number, same everything. Just watch the question for that to understand this, because I'm not gonna re-explain it as it's really long. It's the same number, same everything, so do not worry. It will be the same explanation as well. Consider the curve C whose equation is given by y is equal to x cubed minus 18x squared plus 81x minus 108. Okay, so they want the derivative for part A. We just derive simply into 3x squared minus 36x plus 81, which is what we have here. And then for this part, we're just gonna factor it out. We're just gonna factor. So 3x squared minus 36x plus 81 is equal to 0. So x is equal to 9 and 3. We already have 3 here, so it will be 9. Okay. Here, let's complete the table of variation. So here we'll have y. So it will go up, go down, then go up. We already said b is 9. This next part is to be memorized. So if it's up, down in the table of variation, it's a maximum. But if it's down, up, it's a minimum. Okay. So we know up, down is when it's maximum, which is at x equal to 3. Then minimum is down, up, which is, as we said, x equal to 9. Number 11. Oh my goodness, not this again. Same question each time, but just different numbers. The volume of a reservoir shaped like an open box with a square base of side x is equal to 32 meter cube. The surface area of this open box. Okay, look. We want so this part is the lateral area, which is the faces. Should be one here. So they basically, in this case, want us to find the number of faces. There's one here, one here, one will be here, and one will be here. We do not count. Yeah. Okay, look. The reason why it's x squared, which is because we didn't count the one on top, because there will be an like a base at the bottom, which the area of that is x squared. We're not gonna count the top because they said open box, which is why it's not 2x squared. Okay. In terms of x, h is equal to volume again is equal to area of the base times height. So 32 is equal to area of the base is, this is the base basically. So area of the base, x times x, so x squared times height, h. Okay. Just make it, just isolate h, you'll get 32 over x squared. In terms of x, the surface area of this open box. Okay, wait, let me write it. Here, for this part, we're just gonna substitute h by this. So, 4x 32 over x squared plus x squared. So we just cancel this x and then just make this to the 1, and we'll get 128 over x plus x squared. For the next part, we're gonna need to derive, because we know that by ds by dx. Simply just use this negative 128 over x squared plus 2x. Now for this, just equate it to 0. So you can do negative 128 over x squared plus 2x is equal to 0. That will give us x is 4. Okay, so now that we know x is 4, they want the height when x is 4. So you just substitute it in here. You just substitute x in here, which will give us height is 2 meters. Number 12. The function f is defined by f of x is x squared plus 12x plus c, for x is all real numbers where c is a non-zero constant. The roots of the equation f of x equal to 0 are r and negative 4r, where r is a positive constant. Now look, here we have, in my opinion, my hardest question, because I never understood these rules. Because look, sum, we took this in 10s, is negative b over a. No. That's the product. Product is negative b over a, while the sum is c over a. Am I right? Oh, I am so wrong. Guys, so for this question, I personally, last year, if I was given this question, I would not have understood it. But now I understand it, alhamdulillah. The function f is defined by f of x is equal to x squared plus 12x plus c, for x is all real numbers where c is a non-zero constant. The root of the equation f of x are 0 when it's 0, or r, and negative 4r where r is a positive constant. Now let's write the rules. Sum is equal to negative b over r, where in this case 1 will be a, 12 will be b, and c will be c. Very convenient. And then the product is equal to c over a. Okay. Now let's solve. The sum, which will be negative 3r. Sorry, this is a, because we add these two. So the sum of the roots. So negative 3r is equal to negative 12 over 1, because we said 1 is a. We get that r is 4. Okay, so for the product we do the same thing. It's gonna be the product of the two roots. So negative 4r squared, you substitute r by 4, which will give us c. Now look, c, as we said, is the product. C over a is the product. So the product at the end of the day is c, because a is 1. So it will give us negative 64 will be c. And then for part c they want us to factor it. So we're gonna get x squared plus 12x minus 64 is equal to 0, which will give us 4 and negative 16, which is what we have here. Correct. Okay, now they want the coordinates of the turning point. What we can do to find the turning point, the turning point is basically what makes the derivative 0, and since it's a point, they want the coordinates of the point. After we get that x, which will be negative 6, we'll substitute it in x squared plus 12x minus 64. So we're just gonna derive 2x plus 12 is 0, x is negative 6, correct. So, and then we're gonna have to substitute negative 6 in the original equation. So negative 6 squared plus 12 times negative 6 minus 64, which is negative 100, which is correct. Number 13. The volume of an open box with a square base of side x centimeters is 810 centimeter cube. For x is 9. What's this first part at this point? They said the side is x. Okay. Open box, square base. So the base is a square. Area of a square is equal to side squared. Side is x. X is 9. So we do 9 squared, 81. Done. Okay. We know the volume is the area of the base times height. We have the volume, which is 810. Okay. And we also have the area of the base, which is 81. 81x. So x is equal to 10, which in this case is the height. I wasn't bothered to put it h. Number 14. The curve whose equation is given by x cubed minus 3x squared plus 13 has a local maximum at. Okay. Now, to find the local maximum and minimum, which are the stationary points overall, we're gonna have to first derive this equation. 3x squared minus 6x. 3x squared minus 6x is equal to 0. Because we want the turning points, we're gonna get x is 0 and x is 2. Now let's do the table of variation because they want the local minimum and maximum, just the stationary points, which على الآخر is the table of variation. So x, y prime, y 0, 2, here will be 0 and 0. We'll take the same opposite same as the one as the coefficient of the term with the highest degree, which is 3x squared. So we'll take 3. Same, opposite, same. So here increasing, here decreasing, here increasing. Again, up, down is max. Okay, so and down, up is minimum. Okay, so now we know the x of the local maximum, which is at x is equal to 0, and the value there. When they mean the value there, you're gonna have to substitute in the original equation. So we're gonna do 0 cube minus 3 times 0 squared plus 13, which is equal to 13. And the local minimum is at x is equal to 2. They didn't ask for the value of it at there, so we're good. Number 15. Given a right circular cone of base of radius r and height h such that r plus h is equal to 12. Okay. Question. Given a right circular cone of base radius r centimeter and height h centimeter such that r plus h is equal to 12 centimeters. The maximum volume is attained at r is equal to and h is equal to and 3 volume max is equal to. Okay. So volume of a cylinder is equal to 1 over 3 pi r squared h. We need to find h first. H in terms of r, sorry. H is equal to 12 minus r. Now we're gonna substitute 1 over 3 pi r squared h times 12 minus r. Then we're gonna have to distribute. So 4 pi r squared. Wait, why did I put h here? Who invited h? Okay, anyways, 4 pi r squared minus r cube pi over 3. Then we're gonna derive because they want the maximum volume. So 8 pi r minus r squared pi. Then we're gonna put it on the calculator. We're gonna get 8 pi r minus r squared pi is equal to 0. We're gonna get r is 8. R cannot be 0. It's gonna give you two answers. R is 0 and r is 8. R cannot be 0. Come on, let's be serious. R cannot be 0 in this case. Okay. Now that we figured that out, we can just what's it called? For h, we can simply substitute the 4. We can substitute 8 in this equation. We're gonna get the height is 4, and then we're gonna do the normal volume rule. So it's just 1 over 3 pi r squared, which is 8 times 8, 64, times 4. Don't forget here they said 3 times volume max. So all of that times 3. Just gonna put it in my calculator to make sure. So 3 times 1 over 3 pi times 64 times 4. Do not put it in like this. Just do 1 over 3 pi r squared h, which will give you 256 pi over 3, and then they wanted 3 times the volume max, so you multiply it by 3 and you'll get 256 pi. And number 16, a square of side x centimeters is removed from each corner of a cardboard box measures 21 centimeter by 8 centimeter. Side of the cardboard box, we know the story. Okay, we're just gonna do the same thing. X times 21 minus 2x. For these questions, it's always the side minus 2x times the other side minus 2x. Okay, then 8 minus 2x. Now we're gonna distribute the x. 21x minus 2x squared. Then we're gonna do 8 minus 2x. First of all, 21 times 8, 168x minus 42x squared minus 16x squared plus 4x cubed. Simplify these two, you will get 58x squared, and that's what we'll get, 4x cubed minus 58x squared plus 168x. Now for number 17, the curve whose equation, okay, look, as we discussed before, the inflection point is what makes the double derivative 0. So first let's derive once. F prime is equal to 12x squared. Then F double prime 24x, that's it. Then make 24x equal to 0. 24x is equal to 0. You'll get x is 0, which is the inflection point. Now for number 18, square of side x centimeter is removed, oh my gosh, is removed from each corner of a square, measures 30 centimeter by 30 centimeter, the sides, okay. So we're gonna do x, and then it's 30 minus 2x times 30 minus 2x, which is, at the end of the day, x times 30 minus 2x, all of that squared. Okay. This means we're gonna have, here they want x, so that means we're gonna have to make it an equation, derive it, then after we derive it, make it equal to 0. So, also by the way, it has to like apply the condition from 0 to 15, because what's inside is 30 minus 2x equal to 0, x will give you 15. So then now we're just gonna simplify and distribute. So 900 minus 60x plus 4x squared. Then we're gonna have to distribute 900x minus 60x squared plus 4x cubed. Then we're gonna have to derive again because we want the maximum volume. Minimum volume, maximum volume, basically same thing. So that will give us 12x squared minus 120x plus 900. Now we're gonna plug that into the calculator. 12x squared. While I was distributing, I got the 60x squared wrong. Do not make the same mistake as me, as it's 120x squared. Here it's 120x. Because again, the equation was 30 minus 2x. I didn't take into account this 2, so sorry from my part. Okay, and then after we derive, it would give us 12x squared minus 240. Now it will give you two answers. It will give you 5 and 15, and they're both inside the closed interval. So we're just gonna do the table of variation. X, y prime, y, 5, 15, here is 0, here is 0. Gonna take 12 as reference, so same, opposite same, then up, down, up, and as we can see, it's the maximum at x is equal to 5. Number 19. Consider the following function given my g of x is equal to x squared minus 2x minus 15 to the 4, the value of the gradient where x is equal to 0. So the gradient is the it is the derivative. So we're gonna derive. We're gonna derive this by doing the chain rule. So 4x squared minus 2x minus 15, all of that to the power of 3 times 2x minus 2. And then we're gonna have to multiply this by this, so 8x minus 8 times x squared minus 2x minus 15, all of that cubed. Okay, then here they want when x is equal to 0. So when x is equal to 0, we're gonna get as I was saying, we're gonna get negative 8 into negative 15 cubed. Negative 8 times negative 15, all of that negative 8 times negative 15, or like negative 15 cubed, which will give us 27,000. Function g has how many stationary points? Look, as we know, this part will only have 2 roots. It won't have more, as the roots will be repeated. Each root of x squared minus 2x minus 15 will be repeated 3 times as it's cubed. So we're just gonna have the roots of 8x minus 8 and the root of x squared minus 2x minus 15. So x is equal to 1 or x is equal to, we're gonna do mode 5-3, x squared minus 2x minus 15 is equal to 0, which will give us x is equal to 5, x is equal to -3. Okay, now we're gonna need to do some harder stuff. Basically, we're gonna need to do substitution. So x, y prime, y, -3, 1 and 5. Okay, then we're gonna take, so we're gonna need to basically fill in the blanks here, here, here and here. So before -3, let's take -4 and substitute it in this equation. So 8 times -4 minus 8, all of that times -4 cubed, squared, minus 2 times -4 minus 15, all of that to the power of 3, which will be negative. So this will be done. Then between -3 and 1, we'll take 0, which as we said is positive by part A. Then between 1 and 5, let's take 2. Okay, so 8 times 2 minus 8, all of that multiplied by 2 squared minus 2 be 2 minus 15, all of that cubed, which will give us negative. So here positive, here negative, so here will be down. And then let's do more than 5. So 8 times 5, no, sorry, 6. Since we're taking more than 5, it has to be more than 5, not 5, more than 5. So 8 be 6 minus 8, all of that multiplied by 6 squared minus 2 times 6. Okay, and that will be positive. So let's elaborate basically. As we know now the minimum and maximum. I already explained them like 3 times. So the minimums are at -3 and 5. The maximum is at 1. Finally, this long question is done. Finally, the last question, and it's a question from last week. Consider the function given by y is equal to 2x cubed plus 6x squared minus 48x plus 1. Okay, select the correct option. So for part A, they want us to find the local minimum, local maximum, which are stationary points. We find that by doing the table of variation. To find the table of variation, we're gonna do the derivative of this, which will give us 6x squared plus 12x minus 48. Plug that into the calculator. 6x squared plus 12x minus 48. Make it equal to 0. Okay. Then we have 2 and -4. X, y prime, y, then -4, 2, 0 here, 0 here. Then we're gonna do SOS, same, opposite, same, as the coefficient of the term with the highest coefficient. So same, opposite, same. So up, down, up. So the local minimum will be at 2, negative 55, and the maximum will be at negative 4. Then to find the table of to find whether it's concave up or concave down, we're gonna do the double derivative and basically do a table of variation, but for double derivative, which will give us whether it's going concave up or concave down. So after deriving this, we'll get 12x plus 12, where x will be equal to negative 1. And then we'll do the table of concavity. So x, y double prime, y, negative 1. And then since it's linear, we're gonna do opposite same. As again the coefficient of the highest term, we're gonna do negative, positive, which means at y less than negative 1 it's concave down, and y greater than 1 it's concave up. So again, y greater than negative 1 it's concave up, and y less than negative 1 it's concave down. Thank you guys so much for being patient with me and watching this video. We hope you guys the best of luck, and sorry for rushing as I have so many other exams to study for, and good luck.